So let's start. Hello and welcome to the Intro to Flutter presentation. Today, I would like to share with you our experience with running our Flutter application in production for about 6 months. We will talk about how to organize your code, which libraries to use, and other tips and tricks we've learned so far. But first of all, let's talk about cross-platform development in general. Why are there so many cross-platform frameworks? Why does each framework promise to kill native development? And why, despite all of that, is native development still alive? Let's define which advantages we can get when doing cross-platform development. First of all, it's of course reusing business logic. We programmers are lazy folk, so if something can be done once, we would really like to have it done only once, especially when it comes to business logic, the core of your application, something that should be tested thoroughly and at the same time, something that can be changed constantly over time. Second, reusing UI. Now, this can be a controversial moment, and actually some developers and designers can argue that UI should be as strictly adhering to platform guidelines as possible. At the same time, it's pretty common lately to have a unified or branded UI that is the same across all platforms. And platforms themselves are eliminating difference in both UI and UX. Faster development cycle. Obviously, if we need to implement a feature only once, it's faster than to implement it twice. Of course, if we are speaking about the full development cycle, starting from product discovery through design and up to coding, testing, and deployment, we won't get twice speed up, as there still are some steps that cannot be shared. But there will be a gain in time anyway. Sorry, I've got a question here. Yeah, actually, it's kind of introductory one, and let's talk about it. I started a little with Flutter and almost left the idea because I found it weird that basic things like playing audio are missing. There are people who think that this is actually okay. What's your stance on this? Yeah, like basically that depends on the moment when you started playing with Flutter, because I would say right now, as Flutter is already in a production stable release, basic things should be working. There are still some kind of weird bugs that happen sometimes, but I guess they can happen in any framework. I would say, yeah, Flutter is production ready for now, and basically we have it in production for 6 months, and so we are happy with it so far. But yeah, let's for now continue with advantages of the cross-platform development as a whole. Next thing is smaller teams. Maybe as developers, we are not interested in having less demand for our services, but tech leads and other managers will definitely consider it as an advantage. And the benefit here is growing at a very rapid pace, actually, because managing a team of 3 people is more than 2 times simpler than managing a team of 6 people. As with scaling team down, intercommunication problems are scaled down faster. And the last but not least point, synchronized releases. As you develop a new feature only once, there is a high chance that it can be tested and deployed at almost the same time. Well, almost, because, for example, Apple pre-moderation can take up to several days and it can be asynchronized with your Android release, for example. But yeah, almost it will be at the same time, and it makes life easier for marketing team, for product managers, for support team, since users have a higher chance of getting the same latest version of your app at the same period of time. So, is life that beautiful for cross-platform developers? Well, obviously not. Let's now take a look at drawbacks we can have with a cross-platform approach. First, no matter how good a cross-platform framework can be, we still will have only a subset of features available to native developers. If we want unified experience, then we obviously lose features that are unique to each platform. Non-native UX. Though it can be solved in some frameworks with different methods, if we start to strictly follow platform UX guidelines, we can lose one of the advantages, reusing UI and UX across platforms. And one of the most important problems with cross-platform frameworks, at least with some of them, is a performance penalty. If there will be another abstraction layer, there will be another performance degradation. Or not. Let's talk about it in a moment. The last moment, which is maybe not a drawback, but just a point to keep in mind. Some managers think that one cross-platform developer equals to one iOS developer and one Android developer. In my opinion, that's not true. No matter how good a cross-platform framework is, sooner or later, there will be some problem in interop with some platform. And at that moment, it's better to have a developer who has native experience with this platform. Anyway, it's a never-ending discussion whether cross-platform development is good or bad. The right answer sounds familiar to all architects. It depends. But for now, I just assume that you're at least interested in cross-platform development, so let's continue talking about it. I would like to speak about different categories of cross-platform framework that we can find. These are very loose categories divided by the way they deal with UI. My first category would be frameworks for creating hybrid apps. By that, we usually mean a web view with a common HTML, CSS, and JS app that is placed in some native wrapper, which also provides an access to native platform features, such as camera or geolocation. These are such frameworks as PhoneGap, Ionic, or Onsen UI. And since it's just an HTML application inside, it's very easy for web developers to dive into mobile application development. Also to reuse your web application or to create some prototype. At the same time, the main disadvantages are really bad performance. Due to a huge number of abstraction layers and non-native UI, non-native UI is basically no matter how hard you try, you will hardly make users believe that this is a native app. Next category, which for convenience I've called native UI, is presented by such frameworks as Xamarin, React Native, or Titanium. Their common feature is that they seamlessly provide you the way to use native UI components in your cross-platform application. What does it look like? You develop an application in your favorite language, can be JS, TypeScript, or C# in case of Xamarin. Your business logic can of course be totally shared, and the UI is translated into native UI for each platform. The disadvantage of this approach is again a performance impact. So not as big as in the previous category, it can still be a problem. For example, Xamarin application requires the whole .NET Mono runtime to launch your application. And for some old and cheap Android devices, it can be a really hard burden. React Native also creates a bridge to translate your JavaScript code into native calls and back, which can be quite expensive, especially when we speak about animations. There is another approach, which was, for example, taken by Kotlin multi-platform framework. It allows you to share your business logic written in Kotlin between your Android and iOS app. It will be compiled, obviously, for JVM runtime for Android and into native code for iOS app, which we can call from Swift code thanks to interop feature without any significant performance impact. But both an advantage and drawback of this approach, depending on the way how you look at it, is that you have to implement UI for each platform separately using native methods. So UI is basically not shared at all. And now let's talk about the approach that was chosen by the main hero of this presentation. Strictly speaking, this approach is not unique. There is at least another framework I know with a similar way. It's Kiwi, cross-platform framework in Python. The main idea is that framework does all the UI rendering on its side. It's slightly similar to our first category, but it uses for it a high-performance rendering engine under the hood. In case of Flutter, it's Kia, an open-source two-dimensional graphics library that serves as the graphic engine for Google Chrome, for Chrome OS, for Android itself, and some other products. So, what do we gain when using Flutter? Obviously, we can share the code for our business logic. Next, we can share UI. As the rendering is done by the framework, we have a number of options here. We can have it unified across all the platforms. We can use natively looking components on each platform, or even create some crazy combinations, such as Cupertino components on Android and material components on iOS. And yeah, it can sound weird, but we actually use this mix in our UI library. Some of our components are based on material ones, and other on Cupertino. It's worth noting here that these components are not native ones. They only look like native components, but they were implemented from scratch in the default library. What else? As I've already mentioned, thanks to this graphics engine, we can get a very high performance of 60 frames per second, even for complex animations. And because all of these components are implemented from scratch, we get a really nice UI system built on composition over inheritance and functional compositions principles. And as for me, this UI system is really great compared to iOS and especially Android system of widget and views. And the last point, and the most controversial one, Flutter is using Dart language, and so will you. I know some people who hate this language. I didn't have any good feelings about it as well in the beginning, but now I actually start to like some of its features. Maybe it's just a Stockholm syndrome, but anyway. Let's now talk about Flutter in Mews. In Mews, we love Flutter, and I'm not only speaking for myself, honestly. We use it for developing a light mobile version of our property management system, the one that I'll be talking about in a moment. Another Flutter project that I've already mentioned is UI library. We have actually big plans about open sourcing it in the near future, so stay tuned. We are also using Flutter for different side projects, both to play with Flutter, to try some approaches that can be incorporated into our main app. And we are also actively participating and organizing different meetups and workshops about Flutter, writing some blog posts. So let's now talk about our main Flutter application. This app is a light version of our property management system. For now, it's mainly used by housekeepers and maintenance staff. From the developer point of view, it implements the common set of features for all the business applications, calling APIs, displaying dynamic forms, receiving real-time updates via push notifications, WebSockets, managing localizations, and so on. Speaking of the team, we can say it was built by 1.5 developers. Originally, it was only me. Then we've got another developer, but at the same time, I was doing other tasks and didn't take an active part in the development itself, mainly in code review. The development started in April 19. We had an old version of this app written natively in Java for Android and Swift for iOS. But it was not actively developed at that moment, and the Android version required some major refactoring. So we decided to rewrite it from scratch in Flutter. The first public release was in September 19, and now it's still under active development. We are releasing a new version of the app roughly each 2 weeks or once per sprint. Currently, we have only about 3K active users monthly, but we have a lot of plans to improve it, so we are steadily growing our user base. So what we have learned so far having this app in production for about half a year? First of all, let's talk about the most useful libraries we are using there and in pretty much every other Flutter project, either big or small. If there is a family of libraries that doesn't need any introduction, then it should be Rx. You probably know its implementation for different languages such as RxJava and RxKotlin, RxSwift, RxJS. Dart is not an exception here, and we have a RxDart library. Though there are built-in streams in Dart, and many concepts in Flutter are actually already built around these streams, this library still gives you a lot of extensions, helper functions that are built on top of these native streams. And it is highly recommended, especially if you were using other implementations before. Functional programming and its immutable models as first-class citizens are now in trend. And as Flutter incorporates many ideas of functional programming, it seems natural to go with immutable models. They really help a lot with tackling the complexity of your business logic. Unfortunately, unlike, let's say, Kotlin data classes, Dart doesn't have immutable models out of the box. Luckily, we have libraries that take off some overhead in creating immutable objects. That's build collection and build value. Let's see how we can use this library in our code. Although it still seems to be rather verbose, some of this boilerplate can actually be managed by live templates, and we can focus on the main part of it. So we are just defining an abstract class and number of getters, and the library will generate the code with all the functionality for such things as copying our object with partially changed properties. This is how it can be used. And if you are familiar with Kotlin data classes, you can see some resemblance here. The commented line is the analog of it in Kotlin. Actually, this library gives us even more flexibility because it implements a builder pattern under the hood that supports all the nested structure. This is useful in case if you have, for example, the whole hierarchy of immutable objects and collections. Another moment that will inevitably arise in any app that is dealing with API, serializing and deserializing JSON. Though the build value library that we've just speak about can handle this as well, we find it rather verbose for that. Also, DTOs are even more immutable, if you can say so. If you need to partially copy DTO objects, then you're probably doing something wrong. That's why for DTOs, we actually use a more lightweight library, JSON serialization. It is also based on code generation principle as the previous library and creates some code for implementing to JSON and from JSON methods. This is how your DTO can look like. And again, it can look a little verbose, but it can be also solved with live templates. And we can focus only on the properties of our DTO. And this is how it can be used. Actually, you won't even probably write this code manually, as it can and should be generated by our next candidate. If you have an experience with native Android development, I bet you know OK HTTP and retrofit libraries. These guys know them for sure, and thanks to them, we have DIO, it's OK HTTP analog, and retrofit analog, which are working in a very similar way. All you need to do in order to implement an API client is to define an interface like this. And also the nice thing here is that this library goes perfectly with JSON serialization library. So you can just reuse your DTOs such as empty response and sign-out request here. You are just marking these classes with JSON serializable annotation, and retrofit library will automatically call from JSON and to JSON methods as needed. So we can easily use this client, let's say, in our authentication manager that implements a higher level functionality. And our last category of patterns that always comes out while we are aiming towards a clean architecture is dependency injection. There are several libraries to choose from for that. Our choice is provider library. Actually, it's a mix of state management and dependency injection library, but we are using it for DI only. And as pretty much everything in Flutter is a widget, this library is not an exception. It's just a wrapping widget that gives you the way to define value or factory providers and later retrieve them in the underlying widgets. Let's say we have a message block or message view model that is dependent on messages repository and REST client. Somewhere in the widget, let's say it's messages screen, we are creating our block or our view model and pass the dependencies we are retrieved from provider. Yeah, it's sort of a so-called poor man's DI, and we can actually go in a more complex way to eliminate the need for creating block manually. But so far we are okay with this approach, and this maybe is slight overhead. And actually, thanks to Dart's type inference system, that code can be made even shorter. As compiler already knows what types are expected in constructor, we can omit generic types declarations. Just keep in mind that this code can look rather confusing. So it's up to your team to decide whether you want to use this functionality. Let's now talk about building an architecture and defining proper structure for your application. As this can actually be a theme of several other presentations, I'll try to keep it really short and discuss only the general points. Speaking of structure, there are two ways of organizing your code, horizontal and vertical. Horizontal structure assumes that on your top level, you have folders according to the functionality of classes inside. For example, models, blocks, widgets. This can be tempting to structure your code like that in the very beginning, as it's very easy to define which folder your file belongs to based on its functionality. The problem is that this structure becomes rather messy with the growth of your code base. And to change something in one module, let's say messages, you will have to go through multiple top-level folders. That's why we prefer vertical structure, where your code is organized according to the use case of the module. So on the top level, we can have folders such as profile, messages, and so on. Inside these folders, we can have nested submodules We can possibly extract some shared models into a subfolder, or in a simple case, keep it as a flat list. Let's say in our app, we have a messages model. It means that we will have a top-level folder called messages. For thread screen, we will use shared models, messages repositories, and the screen-specific code will be located in the threads folder. When we go to a new thread screen, we are still using these models as in the previous screen. We are still using messages repository, but the screen-specific code can now be located in the create thread folder. Let's now speak about architecture. As Flutter is primarily a UI framework, it doesn't force you to use some specific architecture pattern. So you're free to use any of existing ones or to invent your own. At the same time, there is a pattern that's becoming a standard de facto in Flutter development. It's block or business logic component. The idea is rather simple, and it's actually similar to Redux pattern. You have a block component that provides you an output stream of states and an input stream where you can send some events. Block transforms these incoming streams of events into an outcoming streams of new states. And the widget is supposed to, at one side, consume a stream of these states and transform them into UI, and at the other side, send events with this input stream. We are actually using some mix between pure block model and MVVM approach. Our business logic component defines a number of observable properties and exposes a set of methods that widget can use. So in the center of it, there is a view model or block that communicates with the widget. Widget knows only about its own view model. It listens to observable properties and transforms it and builds UI out of them. And it uses methods of view model to send events, such as clicks or text inputs and so on. In a simple case, a view model can just change its observable properties based on these events and propagate these changes back to the widget. In a more complex case, view model can use some service, for example, an API service, to retrieve some data. It sends a request and receives a response. It can be both synchronous or asynchronous request. Based on the response of the service, some of its observable properties can change. And again, these changes will be propagated to the widget. Another option for a view model is to fire and forget some requests to a service. After this request is processed, service can independently update a repository, which in its terms can expose its state via stream as well. View model in its turn can listen to this repository state and update its data for the widget later to consume. In this case, widget again receives an updated state through this stream. In any case, widget knows only about its view model. View model knows about repositories and services, and the latest ones know nothing about widgets and view models. This allows us to build a cleaner architecture where high levels don't depend on low levels. Let's say we have a create message thread screen, and there is an input field with the title of this thread. Block provides us a stream of strings with the current title value. So we can connect to this stream on widget initialization and with each update force title controller to use the new value. In that case, our block can contain such a code. For the title stream, we are actually using behavior subject under the hood. But to the client, to the widget, we expose only a stream, so that these clients cannot change it directly, but only through a predefined interface. And let's say we need some method to submit a thread to the server. It can be either creating a new thread or updating an existing one. And creating a new thread, for example, can look like this. We prepare some data and call a method from data layer. Data layer, in its terms, is just an interface, or actually an abstract class, since Dart doesn't have an interface keyword, that abstracts over creating the thread. This interface can be placed into the module with the view model with the block itself, since it's just an abstract dependency for our business logic, and we are not leaking some kind of implementation here. And that means that we can easily implement a stub class for our unit tests, for example. For real application, we need a real communication. So we can create an API thread data layer that depends on REST client and does real API calls. As this is already an implementation detail, we can place this class somewhere at the infrastructure level. So these are the most important libraries that we are using almost for each Flutter project. Of course, there are tons of them implementing UI widgets, native plugins, and so on. But making a detailed review is out of the scope for this presentation. So let's just continue with other tips that can be useful for a production-ready app. Code formatting. This can be a very arguable topic. But, as they say in the army, there are two opinions. One is mine, another is wrong. This is the position of a built-in Dart formatter. There is only one right way to format your code. And if you accept this position, you can actually make your collaboration and code reviewing easier. Like, for example, we did by setting up our CI server. If any of the files in pull request is not formatted correctly from the Dart formatter point of view, the build will just fail and you cannot merge it into master branch. This code, for example, looks quite okay for me. But Dart formatter says that it should be formatted in a different way, only like this. Another moment that can greatly help you with catching hidden bugs and unifying code style is static analysis. And luckily, we have a built-in analyzer as well. So as for me, by default, it's two kind. That's why we went through most of its rules and defined our own importance levels for each of them. Some of them we defined as warnings, and it means that IDE will still mark them with yellow color, but unlike errors, warnings won't prevent you from running and hot reloading your app. That's very convenient because things like, for example, not closed sinks or empty statements can happen while you're experimenting with your code. And you don't usually want to waste your time to prettify your churn code. At the same time, CI servers runs analysis as well, and it will fail the build if it contains errors or warnings. So before requesting a code review, you will actually need to take care of warnings as well. When you start developing with Flutter, you can often come to a situation with a bloated build method that contains a lot of nesting. So when it comes to building a layout, main advice is just to keep your build method flat and readable. For example, with a minimum effort, this code can look much better. For example, one option is to extract some part of your code into a separate widget. And if it doesn't depend on properties of your parent widget, you can even declare it as a constant and even gain a performance improvement. If it's not possible or doesn't seem to be reasonable, you can at least define some helper build methods that will improve readability. What about logging? When we've written our app with Flutter, when we rewritten our app in Flutter from native ones, we've got this picture in Crashlytics. This, of course, doesn't mean that we've suddenly become perfect developers or that Flutter doesn't allow you to make any error in your code. It's only about the way Flutter works. Actually, it's very hard to make Flutter app crash. It can crash if there is an error in the native plugin or in native part of Flutter itself, but errors in your Dart code will just either trigger a red screen of death if you are in debug mode, or they will be just swallowed in production. It can be both an advantage and a drawback. While users won't probably see your app crashing, at the same time, if you, let's say, have an error while displaying a model loader dialog, user has a chance to be stuck at the screen forever. That's why for a production app, it's critical to have a proper logging system. For our project, we are using the same stack as other platforms in Mews. Sentry for error reporting and Rapid7 in SiteOps for all the logging. And you can set up your Flutter app to use these systems pretty easily. And that's it. While of course each of these sections can be discussed in separate presentations, if you're interested in it, we can continue with this how-to series and further share our experience in creating cross-platform apps. Then from our point of view can be even better than the native ones. So feel free to contact me if you have any questions, and let's stay in touch in Twitter, LinkedIn, or directly by email.
Thank you, Kirill, for your talk. And let's see if there are any questions from the audience. I know it's very nice outside, but let's see if there is any questions which Kirill can take. I think you can all now click the button to unmute, but if there is no, then that's also a possibility. Right, Kirill. So how was it? How was it talking to the camera? Talking to the computer?
That's what I do every day, no?
True, yes, but here you had a little bigger audience than, because if you have your stand-up with your team, it's only about four guys. So here it was a little bigger.
Oh, we have a question there. Is it true that Flutter plans to do building web apps? Yeah, there is a Flutter for web platforms, and it's currently in developer preview. Yeah, you can for now play with it. You can compile your application using the same code base for web. The problem is that there are still some not very nice bugs and problems because, yeah, this technology is still very raw. But I like the way they're going there, and so yeah, sometime I believe, of course, it won't kill major frameworks such as like React or Angular, but for its own niche, Flutter for web can actually be pretty interesting. And we actually had some article in our blog about Flutter for web, if I remember it correctly.
Well, if we had, then you wrote it.
If I remember it correctly, I wrote it. Okay, let's say like this.
Was it the one, Are We There Yet, or which one?
No, I think.
Let's see.
I guess it was something
Format.
like, is
I
it a
see it.
killer?
Yeah, I see it. I'll post it into the chat here. Just posted it there. So anyone interested more in the Flutter for web, you can pick up this blog post from the chat. All right, so if there are no more questions, thanks everyone for coming. Thanks everyone. Oh, there is one more.
I don't see it.
You got it, Kirill?
I don't see it. Actually, I don't see chat at all.
Do you use any static analysis except that from an analyzer library?
No, it's more than enough for our properties, and given the fact that it's actually is very customizable, we are using just it.
Cool. So I think that was the last one. So thank you once again. Thank you, Kirill. You are now free to have some beer.
Nice.
All right.
Thank you.
See you guys, and hopefully see you sometimes in person, sometime soon. Bye.
Bye.